Not like a day.
We'll take a day off. There's nothing wrong with the day off. Now we're gonna pile through till the end of the semester.
Which 12?
Gee willikers.
Oh, shucks.
Decay. Three letter word for decay.
Rot?
Rot.
Yeah, rot.
What else we got? Or.
Try.
And try. Which is what you're all doing with object-oriented programming, right? You're trying.
Oh, wait, there is no try. There's do or do not.
This is my segue into today's lecture. So today we're not learning anything new, really, when it comes to object-oriented, just kind of going over what we already know. And then we're going to start putting them into their own files. So that's really what we're going to talk about today.
Awesome.
Today's lab's actually pretty short, which will be good because that'll allow you to start getting into your next coding assignment and hopefully get a chunk of that done. And it is due a week from Thursday. You have 2 weeks, but today is really the big lab day for you to work. That's kind of what we have coming up in the class. Any questions, comments, suggestions? We're good? What do you guys want to make today?
Burger?
A burger?
Yeah.
Kind of mean. I hope you guys ate lunch before.
I ate.
I'm gonna go get in and out on my way home, so what doesn't really matter.
Darn you, Chris.
Who's bothering you? Already made it. We made a car before, didn't we? Yeah.
Well, we had a vehicle class.
So, class burger, right? Burgers have attributes, right, which we kind of deal with as variables, right? And burgers have behaviors. I don't know if behaviors are, but we have behaviors. Right? So what we like to do is we really like to work on our attributes first before we work on our behaviors, right? Because most of the time our behaviors act on our attributes. We have to do that first. You know any attributes of a burger?
The bun?
Patty mount.
All right. So
Bun?
like, care bun type. Is that what you want?
Yeah.
Low carb.
It's like a Boolean, low carb.
Protein
One of the
style.
buns could be low carb.
If you're broke, I can use.
Like patty count.
Yeah.
Patty count.
Yeah, or the actual patty itself.
Patty count.
Cheese type.
Yes.
String. Care. String. You want string? String. Cheese type. This is. I'm getting hungry. I just.
Condiments.
Yeah. Next class, we'll get into how we can handle condiments.
Next class, we're all getting burgers.
Can you guys see that pen at all? Is that a better pen somewhere? This pen is kind of sucking.
That'd be okay if there wasn't like inception happening with what was erased
Right?
into what you're writing.
This is why we need some rubbing alcohol over there. Rubbing alcohol will clean that up.
Yeah, I tried the purple already over here and it was terrible. I'm just gonna put it here for the next professor. Is this blue any better? Is that better?
Yeah.
A little bit.
Why not?
Or I got no.
No.
But now your curly braces are in the wrong spot.
Yeah, my drunken seagulls are flying the wrong way. Right? So, go back to last Thursday, or really the Thursday before that. We learned about these things called constructors. Right? Constructors allow us to construct our objects. They are functions that run when our objects are created to initialize them. Right? So here, I'm probably going to need a constructor to help set up my bun type, my patty count, and my cheese type. Does that make sense? Right, so I'll need a constructor for that. We talked about overloaded constructors, writing multiple constructors of the same name with varying parameters to do that. The other thing we talked about was default arguments, where we can default parameters to values if the user does not supply them. And so I'm going to use that technique for my constructor. I'm not going to overload the constructor, but you'll see how I'm pretty much overloading the constructor without overloading. Right? Constructors are named after the what?
The class.
The class, right? So the class is called burger, and then my constructor is called?
Burger.
Burger. Sorry. Is there a return type? Like int, void, char, string?
No.
No, right? They're just, right? Because they run once.
Because that's the type, right?
Run. They initialize our object.
This is to avoid garbage values.
Yes. No cheese today, sorry. Can't handle the cheese, lactose intolerant.
I'm a lactard too.
No, I just, I don't want to write too much.
No, I really am.
So I'm going to try to initialize my two attributes with my constructor. Does that make sense?
Yes.
Right, but I'm also going to default them, so if the user does not provide values, we'll fall back on other values. Right?
So that's where you do care button.
Right, we can say care button type. Right. Notice, right, these again are parameters. Parameters don't have the underscore. They are the data coming into our functions from some external source. Whether that's, CN, user input, whether that's just you typing something in, or whether it's something else, right? It's coming in from the outside into your object. So we have a button type. What do you want to default the button type as?
Sesame Street.
So since it's a character, we'll do ask for sesame. Does that sound good? Right? Default argument equals S says if the user does not provide a button type, we will default our button type to S. Does that make sense? Super easy. All right, underline it. All right, that's our default argument.
Right.
So I have a button type and I also have a what? A padding count. And to save space, I'm going to start it on the next line. All right, you could probably just type it over and farther. Padding count. Right? What should we default that to?
One.
One.
Seems realistic.
Seems like a good thing to default it to.
12.
And then I'm going to close, right, my opening paren, and then throw a what on it?
A semicolon.
Semicolon.
Of course, you should get a 20 by 20.
Int to put predicate?
No. Yes, I do. Int padding count. And then, right, tab that over. Good, right? Because parameters are like you're creating variables, right? Okay, int padding count, care button type, defaulted to sesame and defaulted to 1. Good so far? Right, once again, what do we call that?
We call that a constructor.
Yes.
Right, constructor. Which runs when?
Once and early.
Once, early, when the object is created. Right? Good. All right. Let's try and add an accessor and a mutator, just so we remember how those look as well. So we'll do it for button type. Accessors get the data, right? So they look just like your attribute, except right, parens instead of underscore.
Oh.
Right. So it just looks like their return type. So it'd be care, right? Button type, right? Open close paren, right? Their whole goal is to get the button type back, right? Because the button type is what? Private. So can you directly access it? No, the only way to access it is via the accessor. That's the name, access.
And that also doesn't have an underscore because that's what's going to go in the value of the
Right, it's going to return the underscore one. So no need for an underscore. Underscores only go on our attributes.
Right.
We also have a mutator, void set button type. Right, and in the parens we say, what's button type? Character, care, button type. Right? So here we have,
Not enough room.
right, an accessor
And a mutator.
Right? Pretty much accessors and mutators always look the same. Right? So I just want to remind us that, right? Whether you fully understand what they do, they always look the same. So just do exactly the pattern and we'll pull out that.
How do you know from the set the accessor and the mutator, that they're both just like implement? I'm something like, because like in the private, they're both just like values. Right?
Yeah.
And so how do you know like, oh, this doesn't have a void?
Okay. You know this one has a void because it's a mutator. It's taking data in, but it's not
If there
sending
wasn't
data out.
anything in the parentheses right there, like found empty, would it just be another accessor?
Yeah. So then what we void. Right?
Yeah.
So set functions always take data in because you want data to come in.
Oh, okay.
Right? And they don't take data out. Right? So we can get a void. Sometimes you'll see mutators have like a Boolean, right? Data comes in, it returns true if the data is valid and it can set it. Otherwise, it returns false, like sorry, I haven't set the data. But for us, they'll always be void with set, right? And the other one will always be the type of what I'm. And theoretically, I should have an accessor and mutator for padded down, but I'm not going to write it. Make sense? Are we good there? Right? Where does all this code go?
Above main.
Above main, right?
I thought you were asking the second part of that.
Right. And then, right, today we're going to learn how to put all that code into its own file. Okay?
Oh, sick.
That file is called the interface. Because
Awesome.
really, right, this is all I need to use the burger class. Okay? I now know that there's a class called burger. There's a constructor that can take bun type and patty count, and I can get the bun type and I can set the bun type. Right? That's the interface. That's what I need in order to use it.
And that's whether you're in main or under it.
Right, exactly.
Either
right?
way, you can still just need that.
Mm-hmm.
Okay.
So this is all really, as an outside user, all you need. Now, obviously, we're writing it as well, so we have to write what we call implementation. Right? What do these behaviors do?
Which is
But overall, this is the interface, right? Really, if you think about it with C and Reader, right, this is what we gave you. The class was called what?
burger.
No, the class was called C and Reader, right? And then there were a bunch of functions, right? Read int, read double, read char. Some of them didn't take input.
Yeah.
Yeah, like read char takes a string as input, right? The allowable character, right? And so once you know the interface, you can start using it even though you don't know how it's actually coded. Does that make sense? All right, so we have this interface idea, what's above main, what we need in order to use it, and then we have the implementation, how the interface is realized in code. Does that make sense a little bit? All right, so we'll get to that today. But right now, I'm in, right, copy and paste. All right, so now below main, right, I got to copy and paste it. Copy and paste my constructor first, right, so I get burger, colon, burger, right? Do my parameters come over with me?
Yeah.
Yeah, right?
Yes.
Which is why we copy and paste. Do the default arguments come over with me?
Yeah.
No. This is the weird quirk of C++. Default arguments do not come.
What?
Right? You said it backwards.
I
You
answered
got
them
both
backwards.
wrong. 50-50 chance on both. So here we just say char bun type, comma, int, patty count. Make sense? What do I need to do with these parameters?
You need to get values for them.
Okay, but getting values, I'll do that in main.
Okay.
Right? So imagine I have values. Imagine these have values.
Oh,
That's
you
normally
need
the
to
best way to write it is just in your head, you're like, oh, patty count is 3, bun type is,
We have to set
W.
them to the underscore one.
right?
Yeah.
Right? So we're going to take the parameter, the input, and store it into our what? Our attribute.
Attributes.
Right? So we're going to say bun type
Underscore equals
what?
fun type.
So if the bun type was S, S gets stored in the bun type underscore. If the bun type was W, W gets stored. So let's, whatever else.
Oh, that's sourdough.
S for sourdough, right? Ciabatta, right? We can do all sorts of things. Right? And then what else do I need to do?
Patty count.
Store the patty count. Mutators are the place where you probably want to do some form of error checking. Right? Does that make sense? Because, right, can you have 0 patties? Well, I guess you could. You can have -1
Because
patty.
it could be grilled cheese.
Right, exactly. But you can't have -1 patties. It'd be like, I would like to buy this burger, and here is a patty.
But what if that's an action you set in so that you can refund?
Well, I mean, so then you would handle that, right? But theoretically, what I'm trying to get at is because I'm taking input and I can't trust input, agreed?
True.
Right? I probably want to do some kind of error checking. I'm not going to, but you should probably do it. Right? Patty count underscore equals patty count. Come on. Is that it for my constructor?
Yeah.
Yeah, right? Constructor's done. I constructed, right? My attribute. My attributes now have value on construction. Right? We can write our accessories and mutators, so we could say char burger colon bun type open close paren curly brace, and all we do here is just return what?
Fun type.
Bun type
Underscore.
underscore. Right? Accessories always look the same. There'll always be, right, the attributes, data type, class name, colon, the attribute's name, parentheses, return, yeah. Right? Always will look the same, right? So this patty count would be int burger, colon, patty count, paren, return, patty count, underscore, semicolon. Right? So that's just always look the same. Right? Mutators pretty much always look the same, but mutators can differ in the fact that that's where you're going to do your error. Right? To make sure you don't get -10 patties. But we're not going to worry about that. Void, burger, colon, set button type, paren, care button type.
So that is where you bring your.
And then here, right, we're going to do that same line. Bun type underscore equals what?
Bun type.
Right? Always the parameter gets assigned to the attribute, right? The parameter gets assigned to the attribute.
But you could say something like if bun type underscore is less than 0.
Okay, good.
Whatever.
You're on the right track. But bun type underscore is my what? My attribute.
Oh, it's your
right?
attribute. Okay.
The data coming in is just bun type without the underscore, right?
That's why I asked. I want to make sure I had that.
So you would say if bun type without the underscore, right, is less than 0, then bun type equals or this character. You get that.
So like if my accessor is less than 0, tell them no.
Exactly.
Okay.
Right? For bun type, it'd be like if, right, that character isn't one of my valid, right? So if I only sell sourdough and whole wheat and
Stretching
sesame,
style.
right? And they ask for G, then I don't know what to do with that. You're like, and you're getting it on a sesame line. Right? Make sense? Everyone kind of get that? Yeah. So, interface, right? Implementation of my interface, right? And so now the only other thing I have to do is what?
Do the file for it.
Well, we're going to do the files in a minute. Right? We're going to write name. Okay, name open curly. Right, let's return 0 at the end. Right, so now I can make a burger. Everyone good with that?
Sure.
A non-edible burger.
A Ron Swanson burger, because
But
this
they're
is going to
making
be
those
meat
now.
and
They
bone.
can 3D print burgers. They cost like $5 grand or something like that.
There's like $1,000 bacon.
Eventually, right, you could go somewhere and have a nice printed burger. Yeah, it's crazy.
Isn't that what McDonald's does already?
So in main, if I want to create a burger, I have to use the name of my class. Agreed? Right? So name burger. Right?
Burger dot.
We're going to call it BurgerPlane. Right? Now, if I say BurgerPlane, that creates me a burger called plain, right? That has 2 attributes, right? Bun type and patty. Everyone agree?
Yeah.
What are the values of these 2 things?
They're defaulted to S and 1.
All right, they're defaulted to SN1 because this says create an object. Every time an object is created, that constructor gets called. Right? So it's looking for a constructor that takes how many arguments?
1 or 0.
0, right? Can I provide any arguments? No, right? So I'm looking for a constructor that takes 0 arguments. I don't have one, but I do have one, right? Because this one says I have 2 parameters, right? So it takes 2 arguments, but if none are given, right, I can default them. So what is it going to do? It's going to default them, right? So bun type becomes S, and patty count becomes 1, right? Bun type is a what? An S, and patty count is a 1. And we take that S and we store it into what?
Underscore.
Bun type underscore, right? We take that S and we store it into bun type underscore. And then we take that 1 and store it into what?
The PC underscore.
Right? PC underscore.
Now this makes sense.
And it knew we were doing it on the plain object because I said burger plain, right? This is when the constructor gets.
So you're doing like the opposite of overload by giving, like this is your backup plan.
Because really, I can call it 3 ways, and I'll show us. There's 3 ways to call it, so it really is overloaded, but I'm using the default argument as an overload, which is a little bit easier than writing 3D functions. But in your assignment, I'm going to make you write 3. It's good math. So we have burger plain. We can also have burger fancy. All right.
What's the
And then
difference?
notice to get values into a constructor, we put parent after the creation of our object, right? So if it's fancy, right, we want what? What do we want to default?
Wheat bun?
Ciabatta, that's pretty fancy. Right, so C for ciabatta, right? And how many burgers, patties does a fancy burger have?
5?
3 by 3.
Mine is beyond fancy, and that's like its own realm of.
That's just dirtbag.
Anyone ever go to In-N-Out when they let you do like 10 by 10s?
I worked at In-N-Out for 6 years.
Or 20 by 20s.
They don't let you go that way.
Well, when I started, we could do 10 by 10s, and then they like shortly after starting, you could only do as big as like the rows of patties they could throw, which was 8.
Okay.
And then they realized they were getting bad press, so they just reduced it to 4. So now you can buy like 8 4x4s and put them together, but they won't
You
sell
put
it
them
to
together
you.
yourself.
Yeah.
Yeah, we'll go see. Go find out. The friend that did it, he said it wasn't the patties, it was all the cheese they did. The things you do when you're young. So anyways, this creates me a fancy burger. Right, fancy. Right, that also has a bun type and its own, right, patty count. But this time, right, C is what bun type gets initialized here. So now I have a ciabatta with 3. Does that make sense? Any questions on that? The only other burger I can make is, right, burger fatty. Right?
20,
Oh, no, that's
20
not
patties.
gonna work, dang, because I can leave off the patty count, but not, right?
Oh, because you are always going to get the first one.
Burger random, right, and I can give it a Z kind of burger, I don't know what kind of burger that is. Right? But what that says is, in the constructor, Z gets passed in the bun type. But, did I provide a patty count? No, so patty count defaults to what? 1.
Maybe that's your special cheese skirt.
Right, yeah. I don't know what it is, but, right? Somehow in my random, right, I get, right, bun type of Z, right, and a patty count of 1, right? These are the 3 ways that I can initialize because I wrote a constructor that can take up to 2 arguments, right? That has 2 parameters, so it can take up to 2 arguments. But because both parameters have default arguments, I don't actually have to provide it. But you'll notice I can't like not give a bun type and give a patty count, right? It always starts off left to right. No, right? So you leave off the.
So you'd have to think in your head, you'd probably
Which
always
one?
want, like, just for example, since we're talking about burgers, say people will sometimes not eat meat, but they'll eat cheese. You may want to leave the meat as the last one so that you have the option
order
to.
And I probably would have switched this order, right? So how many patties do you want? 10. Right, but we'll just give you the default bun, right? Because normally the number of patties changes more than the types of the bun.
Right.
Does it make a little bit of sense? Right? I can also do things like random, right, dot, set, bun, type, right, now I can change to A. Right?
So now it still has 1 patty, but it's a
Still has 1 patty, but this got changed to A because it said go to the set bun type of the random object and give it a value of A. Go to
Which
the
was
set bun
way-
type. Bun type becomes what? A. A gets stored into my random bun type. Make sense a little bit?
It's kind of cool because like void burger set just chilling there, and you can like keep using it
As many
over
times as
and
you want,
over.
right? I
Yeah,
can change my burger to look whatever, however I want it to look.
that's pretty cool.
We're doing okay? I can tell you this, even if you feel lost, you're doing a lot better than you were 2 weeks ago when we first started. That's good. All right, you want today's lecture?
Maybe.
Maybe. We'll see. I kind of set up the lecture already, so we'll see how much of the lecture I have to do. All right. Slow me down if I'm just skipping up. Which, all of it? Okay.
Oh, he was sincere too. He's like, I'll go over it.
That's right,
Oh,
let's do it again.
screw you, guy.
This is the class we were using, right? A class that represents a day of year, which is way more boring than a burger. Right? But here you go, right? How many constructors do I have?
You have 2.
2 constructors, which means they're overloaded, right? One takes in nothing. That's called the default constructor, right? It's going to initialize my day of the year to some values. Hopefully you have documentation that tells you what it does. We'll see that today. And we have one that takes a what? A month and a day. All right, so I have two overloaded constructors. So you can only create an object by passing in no values or passing in what? Two values. That's the only way to create a day of the year. You pass in nothing or you pass in two integers.
On the other example, you didn't put public. Does it, if you don't say private, is everything defaulted to public?
No, I should have put public.
So wait, you couldn't use
I'm going to talk
the.
about that in today's slides, but it defaults to private.
Okay.
So that's public. It was useless. What I wrote on the board was useless.
I thought you could do one with none, one, or two.
On the board, I did that.
With this, because
none,
right,
and what?
one or two.
No, how would I do one? Probably pass in a month. What's day's value? Only by default. Right?
Okay, so you didn't
Not
do.
numbers, but only by default.
Okay, so because that doesn't have int date equals something.
There's no default. So.
Thank you. That clarifies a lot.
So, and we're going to go over that a little bit when I get into overloading again today. You'll kind of see how does C++ take the function call, right? These are function calls. Here's a function, here's the argument, right? Which function does it match? We're going to get into that in more detail today. So hopefully that'll get less. So two constructors, right? One member function that has no parameters and one member function that has what? Two parameters. You notice day has a what?
That's a mutator, right?
Default. It's kind of like a mutator, but mutators are just for one attribute. It is mutating stuff, but it is.
Because that's input. Void input is the mutator or no?
It's like a mutator.
Okay.
Mutators will always be named set underscore. But for input, I can provide a month and a day, two integers, or I can just provide a what?
Month.
A month, and it will default the day to be one. Right? So that function can be called two different ways, with one integer or with two integers. Right? But the top functions, right, the constructors have to be called with no integers, or really no arguments at all, or two integers. Right? There is no in between.
That
Good?
was really good that I cleared that up.
Yeah.
I thought I had you there.
So let's talk about design, interface, implementation. Then we'll talk about separate compilation, which is putting it into different files. And then we'll go a little bit over it. All right. I think I kind of pretty much talked about this, right? Encapsulation says we don't need to know the details of the class, right? Basically, whatever's private, we don't have access to anyway, right? So does it really matter? No, right? What we need is the public section, right? And we call that the interface, right? What do I need to know? Name of my class, the names of the functions, what they take for input, and what they return. Right? That's really all I need to know. If I know that, I can use it. Right? C and reader, what do I need to know? Name of the class. Well, it's C and reader. Right? Name of my functions. Read init, read char, read double, right? Whatever, right? What do they take for input? Oh yeah, read int takes a lower limit and an upper limit as optional. Right? That makes sense? Those are the inputs. What does read int return? An integer, right? What you get from the user, right? Those four things is all you need to know about a class in order to use it. And we call that the interface. The public section of our class is really our interface. Right? So we call that the interface. You'll also hear it called an API, application programming interface. APIs are useful, right? When someone's written this big library of stuff and you're like, okay, great, read the API, I now know how to use it.
That's what API is.
Yeah, I keep hearing about it all the time.
Here's where the Storm doesn't have an API, so we're all like community wants it.
Yeah,
They won't.
APIs are nice. Right? So the API consists of two things, right? Comments, which are actually probably almost as important or more important than the actual code, right? What does it do? So you can have a function called readInt, but if you don't know the readInt function, right, this is what the input means, this is what the output means, this is what it does, but it's not really that helpful.
It's kind of like the pseudocode.
Yeah, those are your documentation, right? Really important. All right, and then all your public member functions, right? Because the public members are the things that you can use. Those are the only things you care about. You don't care about the private stuff. Doesn't matter, right? Just the public stuff. So C++.com has a reference built into it, an API. That's C++.com/reference, right? So we're gonna look at the string API, right? we've said the secret before, right? That strings are actually classes. Have I said that? Right. So strings are actually classes, which means that a constructor runs when they get created, and they also have public member functions. Right. So we're going to look at the API of that and kind of see how we might be able to use that to do cooler things with strings. In the last 2 days of the semester, I'll teach you, right, the API.
The last
You
2
can count
days.
characters, and you can like, make characters go up and down, all sorts of fun stuff. But for whatever reason, I say that till the end. Yeah, the last 2 days of the semester. But if you go home and read the API, then you can come back and be like, oh yeah, that's easy.
One of my clients was talking about 31 being like he was saying he can't see how that could be an entire semester's worth of stuff.
It couldn't be if it was just HTML and CSS, but then we added JavaScript.
Oh, there is JavaScript in it? Okay, cool.
It was just HTML and CSS, no way to do it. All right, here is the string class, which we bring in when we include string, or as we figured out, also comes in when we include IO string. Right? So this is part of the API, the interface. Class name is what? String, or technically std::string. Let's just not worry about that. All right? Here it says the string class, and then it talks about what strings are. Right? Those are the comments, right? Saying this is what a string is. All right, let's get down to some of the more exciting stuff.
Member function.
Right, member functions, right? And notice one member function is called what? Constructor. Right? Which technically it's named string, right? Because that's the name. But you'll notice that there are a bunch of constructors for string.
Did you click on that?
Loads.
Wait, did you click on constructor?
I did. I opened up a new tab. You have your middle click, it opens up a new tab.
I'll never do that.
So it has a default constructor, string, right? And somewhere down below it tells me what that does. Strings by default start with the empty string. So strings do not start with garbage because they have a constructor that runs. They start with basically open quote and closing quote with nothing in between. Right? So strings never start with garbage because they're a class object.
Is that why when you type string, the program usually
Different
pops
color.
it up?
Yeah, it's different color, right? You can, right, with a string pass in another string, with a string pass in, right, a quoted string. Right, let's not worry too much about those.
Would that be like if you were giving a value, but you wanted it to always say years old afterwards? You would implement like this value years old.
No, because the string just holds whatever, right? So you could store it in like a constant string. Don't worry about the ampersand. I want to show you something that maybe we understand. We'll understand the ampersand in like a week and a half. Let's look at this one, number 6, the fill, right? Notice the name of the constructor is what? String, right? Because it's a constructor, it's named after its class. All right? That says int. That does not say size t, that says int, okay? Everyone good with me so far? That says int,
sure?
int, right? Comma what? Char c, right? So this constructor for input takes an integer value and then takes a what? A character value, right? This is my favorite one, that's why I'm talking about it. What it does, notice it's called fill. So it's going to fill up your string with this many of that character. Right? So if I want to create a string with 100 E's, I don't know why, but if I did, right, I could, right, do something like this. No more fancy burgers or plain burgers.
In what situation would you use that?
I'll show you. Actually, I'll use it. I'll use one that makes more sense than E. Right?
X for hardcore.
String new lines. Right? Now to call this like that takes values in, what do I need after the name of my variable?
Parentheses.
Right? And let's say I want 100. And what do I want? I want what?
New lines.
So then I can do character \n close character, right?
Oh.
And what did that really make? I made a variable called new lines, right? Who inside of it has what?
100 new lines.
Right? So on and so forth. That might be the only place that you would ever do that, but if you need a bunch of one character, then that can be.
What if you were like doing
like front end stuff, and it would look cool to have X's across separating.
Yeah. And then there you go, right? You're like, I don't want to type 1,000 X's, I just want to say 1,000 X's. Right? So what I'm basically showing you is that the documentation, the API, will tell you how to create, right, the constructor, right? What strings can you create with what constructor?
Would that be how you could make like, oh, never mind.
The documentation at this point is useful and not useful to you because when you read their API, they assume that you know everything about C++. Only what? Don't know everything about C++.
Yeah.
That's why you're in this class. I kind of give you some of the API stuff, right, without you having to read it like that. If I go back, right, the other one I want to show you is this one called size. Right, so this is not a constructor, this is a function you can run anytime on any string. Right, because strings are objects, right, which means they have member functions, right?
Under capacity, right?
You notice that it's called what? It's a public member function, which means I can use it. Agreed? Right? What does it return? Not size t, right? It returns the length of the string, and its return type is not size t, but what? Int. Right? So, don't worry about the const. I mean, you've seen const before, you've just never seen it there. So the function name is size, and it returns an integer. Right? And what does it return? It returns the length of the string in terms of bytes, but every character in a string takes up 1 byte, which means it really just returns the length of the string. Right? So if I said string new lines, and then I said cout, right? New lines. Am I doing size? No, I'm doing size. Right? What do I expect it to output?
100.
100, right? This function has a return type, which means that it returns a value when you call it, and what it returns is what? The length of the string. Right? So this, right, outputs 100 because the size of my string was 100 characters. Does that make sense a little bit?
Yeah.
Right? Do I need to know how it figures out how many characters are in the string? No, right? I just need to know that if I have a string, I can call the size function and it will tell me how many characters are in it.
It even has an example.
Yeah, if you scroll down, it has examples, which is kind of nice.
It's cool to implement
How do you
the
use
bytes.
it? There you go. This is how you use it. Create a string called test string, and then the size of the string is 11 because test is 4 and string is 6 and the space is 1. 4, 5. Does that make sense a little bit? Right. So the API
String
can be
is
useful.
11 bytes.
Right.
Period.
It says bytes, but every character takes up a byte.
No, I was just making sure I read it like how it.
And then there's other ones. There's one called length and string, which is the exact same thing as size. Right? I used to use length, and then I'm like, that's like 2 more characters. Or 1 more character.
You'll never get that extra character back.
For me, so now I just use size. Right? Ever kind of have an idea about what the interface is? It is the public member function, the class name, and what they do. Anytime you want to go look at a 90s era website, right? You just go to c++.com. Doesn't it look so nice? Anyway,
It's a great front end work.
they knew what they were doing. The implementation is how the interface is realized in code, right? You wrote the interface, you said this is what it does. Now you got to write what it actually does. This is what you're doing for code assignment 3. You're going to write exactly what the interface is supposed to do. So I wrote the interface, and you're going to write the public member function definition, what they do. So it's everything else. Why do we care? Well, we want to just give the user what they need. So the user could look at just your interface and figure out how to use it, right? If you have good documentation. We don't need to look at your implementation, so we like to separate this. Right? Also allows multiple people to work on the same project. If you flesh out the interface first, then everyone can pick one of the things in the interface and write that piece, bring it all together, and it should work. Right? Because you know what it's supposed to do.
Unless you're missing a semicolon somewhere.
Unless someone's not pulling their weight. Okay, good. Interface implementation. Really, what we're talking about is above main and below main, right? It's pretty much what we're talking about. All right, just so I don't lie to you, structures and classes are technically the same thing. Right, so anywhere you use the word class, you can also use the word struct. Right, that being said, when we talk about object-oriented programming, we talk about classes. So I recommend you use the word class and not the word struct.
You talked about that a little bit last,
Yeah, right?
maybe like a
Sometimes-
month ago when
Yeah, I forget
before
which-
spring break.
there's three just classes,
But you
I
said
don't remember
like
what.
class is more conventional because more languages
Yes, use class.
you'll recognize it more that
Construct,
way.
like in C, means something more of what we define in this. Technically, the only difference is structures by default are public and classes by default are private. Other than that, they're the same. But we'll look at them as the fact that classes have behaviors and attributes, and structures only have attributes. And that's kind of how we'll group the two. Questions on that? Interface, implementation, body blocks? Yes. If you need to store data, then a struct is what you want to use.
So like, okay, cool.
So let's say, I mean, this is what I know. This is an example of what in the algorithms 2 class they're making a convenience store or a vending machine. I don't know, right? So the vending machine, let's say it's a vending machine. Vending machine is made up of items, right? And items have a name and like a quantity and a price. Right? Those are just attributes. Right? So they don't necessarily have behaviors, they just have attributes, right?
Oh, and where
And
they
so
are on
they
the
can create a structure for item, and then they can create as many items as they want. They just need to sort it out. And then what we'll learn on Thursday is that you can put all those in a thing called an array, so you can put all the items together. So yeah, structures actually are quite useful, but only when you're trying to store data. If you want behaviors on that data, that's for classes.
Can you have like a burger class and like a salad class talk to each other?
Yeah, you could, right? We call that message passing.
Okay.
Right, when objects talk to each other, it's message passing. Right?
If you create like a vending machine, to store a bunch of data and not really do any behaviors to it, just say store it.
Right.
But you also know that to have CPP stuff. So somebody can buy something out of that vending machine. You also behaviors. Would you want a separate structure just to keep the data and class to?
No, you would keep the data and the structure and the data and the behaviors of the vending machine together.
Okay, so
But that vending machine could itself have one of the attributes be, right, the items in it. Now I'm just clicking through stuff. We're all, don't worry about it. So I kind of hinted at this. We're going to divide our program, right? Interface is going to go into one file, implementation is going to go into another file, and then main becomes the third file. Okay? Lots of reasons why. One of the big reasons is that you want your class to be portable. Okay? Imagine if C and Reader was just one file, right, with its own main. So when you went to write assignment 2, right, you would have had to gone into the C and Reader file, look at the main, like delete everything, right, and then start writing your own program. Right? Which doesn't sound good, right? Because you only ever have one main. So what we do is we separate the interface and the implementation, and those two files can move from place to place to place. Right? One's a .h file, and one's a .cpp file. We'll look at what we do with those. So the interface file, called the header file, right? It's all the code that was above main. All the code above main, interface file, .h. Right? Should be a name for your class. So if your class is called my class, then the name of the file is myclass.h. Right? Your class is called burger, then the name of the file is what? Burger.h. And you would put all the code that was above main into that file. Okay? A couple other things we're going to add to it, but nothing too complicated. Right? You want to put any of the includes that your class needs into this class. So if you're going to use cout, you better include IOStream. If you're going to use string, you better include string, right? You need to include in your header file all of the libraries you need in order to make your class work. That makes sense? So includes using statements, which also happen to be where in your program usually? Above main, right? So we're still talking really about all the stuff above.
every time you using something C not required to say what you're using main because it's already built.
Right, because you included it. Anyway, all include does is says when your code compiles, it goes and it finds that file and copies and pastes it. But that's all done magically.
Did Voight just make Scene Reader for like Butte's teaching, or do like random people that are making stuff know about Scene Reader?
No, just for here.
I'm sure other people have their own version of it.
People, yeah, and people get used to, like, one of the things that people do and get used to is just writing their own user here. user interface input. So it's super important. And sometimes when I teach algorithms too, I make my students do it.
Nice.
So by the end of it, they wish that. They're like, I'm okay with seeing it. It doesn't matter. Let's not do anything else. These H files, we're going to find out, get included from multiple places, which can cause problems because basically the code gets copied multiple times. You can't have two classes with the same name. That's a problem, right? And so to prevent this, there's one other thing we have to do in our H file. They're called header guards. So they start with the pound sign. We say pound if index or if not defined, and then we just write a random string, and then we say define that random string. Okay? My recommendation is last name underscore file name underscore H, right? You want it to be unique. And then at the end of the H file, you want to say index, right? This prevents your code from being copied and pasted too many places. And you'll see me write it in my example here. I'm kind of good with the interface file. Everything above main plus header guards. That's really all it is. Everything that you did above main plus header guards, and you're good with the H file. Right? Implementation file is everything below main. Right? It's going to be named after your class and with a .cpp, like all of our normal files that we've been doing. Right?
So that's its own file.
Right? Now, it needs to know about your class declaration, right? Because you're defining the function. So in that, you need to include your header file, because it has to know about the burger class you just wrote.
So are we now working on with 3 files?
3 files. This is file 2. File 1, H file. File 2, implementation CPP file. We'll get to file 3.
Is that one like the main?
That's main.
Okay.
So what you write below main, you now put in this other file, and at the top, you just include your H file of your class. Right?
Is
So
it
the H
in
file
quotes?
gets header guards, the implementation file gets the include of the header file. And then we get it.
When you're including it, do you use quotes like that?
Yes. When you include files, you use double quotes. When you include built-in libraries, you use alligator.
Got it. Thank you.
And that file, right? So we put that file in the same directory as what you main program file, a lot of times you'll hear it called like the driver file, right? It's the file with main, right? So it's not above main, it's not below main, it is what? Main. It also needs to know about your class, so it needs to include the H file, right? You only ever include H files. Don't ever include CPP files, only H files. Right, so you need to include it, right? Really, if you think about it, it's the same process that you always did for C and reader. Right, at the top of the file, you say pound include C and reader.h. And then in main, when you want to create an instance of C and reader, you just say C and reader, right? Now it'd be like include burger.h, and then in main, right? Burger fancy, BurgerPlane.
So if your keyboard has a driver update, is this what gets updated, that file?
Sometimes they're H files. A lot of times they're C files.
Okay.
Most of the drivers that are written for your computer are C files.
I just recognized you calling it driver, so.
No, that driver, we just call it driver. It drives your object. Right?
So let's go over to the next question. So, anytime you want to include something, it needs to include all 3 files.
Does it need different pieces are going to all 3 files? Above main is going to one file, below main is going to another file, and then main becomes a third file. Both of your CPP files need to include your H. Does that make sense? Yeah, okay. Now we're going to go through an example here.
It's kind of like the swapping values. You need to create like a third one to move it.
A little bit, but you need 3 things, but we're not going to be moving something. So I can get a Dell workspace. All right. In lecture 13, I'm going to create a couple files. Right? I'm going to create a my_class.h. Right? I'm going to create a my_class.cpp, and then I'm just going to create a main. Right? Main.cpp, myClass.cpp, and myClass.h. I'm going to open them up in the order that I'm going to work with. Right? Normally we write what's above main first, so what am I going to write first? I'm going to write what's above main. Right? And by write it, I mean I'm going to copy and paste it at the top. Right? So Lines 2 and 3 are the new things, right? Header guards, right? Pound if not defines after on my class H, defines after on my class H, right? The key thing is that both of those things after them, after my class H, they have to match. If they don't match, you're going to run into a problem. Okay? At the very bottom of my program, right, I have an indent, right? Telling me that I'm closing the header. And after that, it's just all the code that's normally above main. I get IOStream, I get using statements, right? Here's my class with a constructor and right, an output function, and then one. But this is all the code that used to be where? Above. You'll notice though, there's a little bit more that you should have, right? And that's documentation, right? This is my interface. So you'll notice at the beginning of my class, there's documentation of what the class is. And then every function has its own documentation as well. Every function should say what the function does, because it's part of the interface. This is what other people are going to do. Does that make sense a little bit? All right, so I'm going to save that. Now, that's above main, and so now I'm going to take the code that was below main. The only thing I have to do in this file is also include what was above main. So I'll say pound include. Oh. Include, right, and in quotes, I'm going to include my class dot H. Right, and then I can write my, right, my member functions, my class, paren, right, num underscore equals 0. My class, colon, output.
Would that be void?
Yes, it would. I said something, right? Void, my class output, right, cout. Right, the number is num underscore. Once again, this is just the code that usually would have been where? Below main, right? Only thing is, because I don't have the code above main, I have to include it. I'll include my class. Now main becomes this really small file. I need to include my class.h, right? And then I just need main. And main, right? Create a my class object. So my class object, and then object.output. Kind of crazy, but did I use cout in main?
No.
No, did I use string in main? Did I use anything else in main? Not really. So did I include anything else? No, I'm not including IOStream. I'm not using inline or anything like that, right? Because in main, I don't need it, right? The class will do it, which is why I included class. So then here, just do that. 3 files. What was above main, the H file? What was below main, the CPP implementation file? What is main, your main CPP file? Good question. So the question was, how is main getting the implementation? Because I'm only including the what? The H. The CPPs come in at compilation time. Okay, and I'll show you what I mean by that. So I'm going to run it. All right. You notice that did it compile? No, it said undefined reference to my class, and my class output. Right? Those got defined in the implementation file. Right? So apparently with the compiler, it hasn't drawn it together. Right? And that is because Cloud9 by default only compiles your one CPP file. Remember, I wrote the runner that allows you to compile multiple CPP files. And so when I run it now, it actually compiles all my CPP files. So the compiler, when you're making a program that has lots of CPP files, you always compile the CPP files together. And the CPP files include you. So now that we're working with multiple files, we need to use that C++ assignment. Good question. Other questions?
Can you go back to main for like 2 seconds?
Okay,
got it.
All right, 2 seconds for that. Got one more thing to talk about. You guys ready for that? Handle it. everything I typed here also, right? If you just go into your lectures and go to lecture 13, right? Those 3 files are there. Instead of main, it's just called separate compilation. It's all there.
Wait, where did he?
All right, let's talk about overloading and problems that we can run into when we overload. Remember, overloading is the concept where I write multiple functions with the same name. The only way I can do that is if I differ the number of parameters and or the types of the parameters, right? So 1 parameter versus 2, or 1 integer versus 1 double versus 1 string. Both of those are valid ways for us to overload our function, right? And so let's talk about when we call a function, how does the compiler match the function that we're calling? Right, so the compiler is going to check both, right, the arguments and the types of the arguments, right? Arguments are the values passed into a function. Arguments are the values passed into the function. So arguments get plugged into parameters. Okay? So when I call, right? When I call a function, right?
First define here.
When I call a function called f, and I pass in 1, 2.0, right? Really, what the compiler looks at and what C++ looks at is it says, okay, function name is f, right? 1 is a what type? And 2.0 is a
Double.
double. So it is looking for a function called f that takes a what?
Int and a double.
And a double. Does that make sense? So that's how C++ matches the function it's looking for. And if it can't match it, it'll say, right, no match for function called blah, blah. Right? And we might see that in a little. Right? So we can overload, right, multiple functions with the same name based on the number of parameters, types of parameters, right? You cannot overload based on return type. So notice here's a function f that takes an integer. Here's a function f that takes an integer. Right? Notice I changed the return type, but C++ only cares about name of function, numbers, and types of parameters. Right? So it doesn't know, right? If I called the function, if I said f paren 1, right, it wouldn't know which function to call. It's not going to guess. Right? So you can't overload based on that. You can't overload based on constant versus a normal variable. Right? If one was int num1 and one was const int num1, right? It can't differentiate between those two. So let's look at some examples. Right? Here's my function called mpg. Right? It takes 2 doubles as input. Because it has 2 parameters, so it takes 2 doubles as input. Right? So if I say this, right, mycar.mpg 45.2. This says, look for a function called mpg, right? Oh, look, there's a function called mpg that takes how many arguments?
2.
2. Does this take 2 arguments?
Yeah.
Yes. And then it says what types? What types are these arguments?
Doubles.
These are ints, and this takes what? Doubles. So does it match? Not technically.
It'll
right?
do it, but not.
It'll do it, and we're going to get into that, right? Because you'll notice the top of the slide says what?
Automatic type.
Right? So remember, automatic type conversion, or I call it type coercion, is when a type gets coerced into a different type. Right? So this says, actually there is no MPG function that takes 2 integers, but I know how to convert integers to doubles. And there is a function that takes 2 doubles. So I will automatically convert the values. Does that make sense?
Is there
this will work, I'll call that function.
Is there a way, or is there really a scenario where that would be awful for that to happen?
In a minute. That's what we're leaving out.
Because 45 divided by 2 is you're gonna want a double for that answer.
So let's look at this. We just did that. Yay. Here I have 2 functions, right? So now when I call, right, because it's overloaded. So now when I call an MPG function, it says find an MPG function that takes 2 integers. Right? Well, I have 2 functions that both take 2 things, but one of them takes 2 integers and one of them what?
Takes 2 doubles.
So it will match the first function exactly, it will match the second function, but it'll have to type convert how many times?
Twice.
Twice, right? Both of the arguments have to get type converted to double, which means that really it only matches one, the top.
But that's where your problem lies, because you actually want.
If I wanted to call the other one, right, what do I have to do? I want to say 45, I'd say 45.0, right? And 2.0. Does that make sense?
The problem would be 45 miles is not 45 kilometers as well, right?
We're going to get into the C++ problem in just a second. All right, so call the other one, right? I need to pass it in double. Call the other one. All right, but you can get into problems with the fact that C++ is automatically trying to type convert for you. We're going to see that right here. That's a lot. We're going to talk about this.
Okay, so
the rules are, right, I kind of said that, it will exactly match the function if it exactly matches. So if the number and types of parameters match, that's the one it'll call. If it doesn't, it'll do type conversion, and they'll kind of do type conversion on the level of, do I have to convert 1 time, or 2 times, or 3 times, right? And all the 1 time functions happen first, 2 times second, 3 times third, so on and so forth. But let's look at this problem, right? I have 2 functions, both named add, right? One takes an integer and then a double, and one takes a what? A double and then a integer. So let's look at a function call and let's see how C++ would match. Double. Right? So here's my call, right? This says look for a function called f, right? That has 2 parameters, right? Because I'm passing in 2 arguments, right? Do both functions have 2 parameters?
Yes.
So then what does it look at next? Types of your parameters, okay? 98 is a what? And 99 is a? Do either of these functions take 2 integers? No. So what's C++ going to try to do?
Do the one with the first int it sees?
Well, we're going to find out. It's going to type convert, right? So let's look at the first example. Does 98 go into the integer without type conversion?
Yeah.
Yes.
Does 99 go into the double without type conversion?
No.
So how many times does it type convert?
Once.
This function. Does 98 go into the double? No. What does it have to do?
Type convert.
Type convert. Does 99 go into the integer?
Yes.
Yes. So how many times does the second function type convert?
Once.
Once. So the first function type converts how many times?
Once.
The second one converts?
Once.
Once. That's a problem. Okay? Because C++ says I have 2 functions with type conversion, the same amount of type conversions. I match both of them. Right? So this problem is called ambiguous overloading because C++ does not know which one to choose. And code does not like to make guesses, right? And so this actually is a compiler error. It's not going to work, right? And you're going to get an error talking about the call for a function, whatever, is ambiguous. It's an ambiguous overloaded function. Right? They both get called.
So you could just change one
If you
to.
say they both get called, then really it means what? Neither get called, right? You got to compile it.
You just change one to like my class E.
Yeah, you could change it by making this like 98.0 or this one 99.0, right? But if they were both doubles, you'd run into the same problem, right? If they're both doubles, it type convert once here, and it would also type convert once. So they both do that. So C++, when it matches functions, looks for the name of the function, right? The number of parameters, and then the types. Right? And it goes through those. And if none of those 3, if the first 2 match but the types don't match, it will try to type convert for you. If it can't type convert, it won't compile. If it can type convert but it matches more than one function, it won't compile. But if it type convert and it only matches one function, then that's the one that will. Right. Well, it wouldn't because if only one of them was defaulted, then it'll match the one, not the other. Because it's key, it has to find a function that takes 2. Or if I didn't have that, it has to find a function that takes 1. Whether that function just has 1 parameter or whether it has so many defaults that it only, right, you can add one.
Why would you write it like that though in the first place?
Well,
Okay, thank
I mean,
you.
I wouldn't write that. Right? You would never write a name of a function called add. I just wanted to put it on myself. But there are times where you will write functions that take different things and you can run them. most of the time with Constructor. All right, let's look at this last example. Right, same class that we just had. Right, you'll notice that. Fit them on here. Right. Here, object.f1 5.0, which is going to match right the first one, right, an integer and then a double. Right. This line is going to match a double and then an integer, which we have. Right, but the third line, f1, 5 matches both of them. It matches both of them with how many type conversions? One. So both of them match with one type conversion. We get that idea of ambiguous overload. So if I run it, and I get something says error, call of overloaded f in int is ambiguous. So you notice that C++, when it compiles, takes your function call, right, f1, 5, and really it translates to what? F int, n, right? It translates it to the types to figure out what's it supposed to match. And it says, I can match this one, and I can match what? This one. So I match 2, right? If I match 2, but we don't ever call one function, that's a problem. And that problem is called ambiguous overload. Make sense? Questions there? All right. I will go over your lab here in a second, but I want to talk about your coding assignment first. All right. Your coding assignment should be yeah, but you can run the same hall with autos as well. It really depends on the situation. Sometimes auto is helpful because now you're basically saying, if you're going to do the same thing, whether it's 2 integers or 2 doubles or mixed, right? Then it'll actually figure it out for you, and you won't ever have to do this. But there may be time to do this for that. Let's look at assignment 3B. Right? Assignment 3B is made up of 3 files. Guess what? An interface file, .h, implementation file, .cpp, and a main file, also .cpp. All right, so we get distance.cpp, implementation, distance.h, interface file, right, what was above main, and then distance unit test.cpp, which is the main file. Okay, I've written the H file for you, and I've written the main file for you. Okay, so really in assignment 3, your only job is to write the implementation file. Which will be copying from the H file and pasting it into your implementation file. Okay? Let's talk about what assignment 3 is doing. Because in assignment 3A, you just stubbed out some functions, but I didn't really tell you what was going on. Right? But we knew the class was called distance, so it has to be doing something with distance. Let's talk about that. So in assignment 3, you're creating this class, and this class stores it has one attribute, so it stores one value. And that value is not distance underscore. That value is meters underscore. Okay? So your distance object only stores one value, and that is meters. Okay? Your object, though, is a conversion object. So it can translate meters to other units of measure. In fact, they can translate miles to kilometers, and they can translate fathoms to centimeters. They can do all those things. But internally, it always stores things as what? Meters. Does that make sense a little bit? Right, so let's talk about what I'm going to have you do. So remember, the interface not only has the name of your class and the name of your public functions, but it also has documentation. All right? Now, I wrote documentation, so you should probably read it. It tells you what you're supposed to do. All right? So here I have this class called distance, right? It has 3 constructors. Default constructor, constructor that takes meters, and a constructor that takes other stuff. Right? Each of the constructors tell you what they do. All right? And then on top of that, you have all the other functions that you stubbed out. So it's all the functions you stubbed out in assignment 3B plus 3 constructors. Overloaded constructors. right? And you get, right, here's a mutator, right, line 65, right? So you have a mutator called set meters. So you can call set meters, right, you can pass in 5, and basically that says, bring 5 into my object, right? And so meters underscore becomes what? 5, right?
Are your comments for what's above?
Yeah, comments always go above the function.
Okay.
So this function here's comments are here. It's always above. Now that's my mutator. I also have an accessor called meters. So when I call meters paren, well, what comes out is what? 5, right? 5 comes out. Yay, we can store meters and get meters, right? The hard part is all the conversion stuff, right? And so we have a function called something. Set distance, okay? So we have set distance as a function as well. Set distance takes a distance and it also
Takes a care.
takes a character, and that character relates to a unit of measure, right? E for meters, K for kilometers, C for centimeters, M for miles, F for feet, I for inches, A for pounds. So if I said 5 and then an I, right? That says that I'm setting a distance, and what I have is 5 inches, right? So 5 inches, though, what do I store inside of my object? Meters, right? So do I put a 5 here? No, what do I put? Inches converted to meters. So it's probably pretty small, right? Yeah. Let's just make it up. Probably bigger than that. But something like that. Does that make sense? So you always store things as what? Meters. Right? Other units can come in, but internally you store them as what? Meters. The same way you can get a distance, right? So I can get the distance out as fathoms, right? And so then it would take 0.02 meters and convert them to what? Fathoms, right? So that comes out as
Even smaller.
I don't know, it's even smaller. I'm not making you do things like hands, or leaves.
16 hands was my grandma's horse.
Yeah, right?
Yeah.
There's weird measurements. But anyways, so that's pretty much it. It's a conversion thing.
No, they made
Bring
horses
data in, but always store it as meters. Get data out and convert those meters to what the user is asking it to be. Okay? I wrote the H file. I wrote the unit test. Right? And so your goal is to write the implementation. So really, bring in your 3A stub functions, add 3 more stubs for your 3 constructors, and then compile. Right? Then once you have compiling, then start working on what they do. Right? What are you supposed to do? Read the comments, and the comments will tell you what you do for each individual. Make sense, everyone? Yeah, you guys write the conversions. So you can just look it up on Google. Google does a really good job, right? On Google, you just say you say 1 meter to fathom.
Oh, God.
Right? They give you a little drop down, right? So 1 meter is 0.54 fathoms, but then you can do it for kilometers, or you can do it for
Very nice.
micrometers, which I'm not.
That's pretty tiny. That's a lot of micrometers. Never mind.
Right? What's going to happen is when you run the unit test, it's going to say your value, and it's going to say correct value. So your value should match the correct value. Now, if you're off by like 0.00001, that's fine, right? So you're not going to lose points if the conversion factor you're using is less precise or more precise. But if you're off by 1 or even 0.5, then you probably have the wrong number. Does that make sense? Good?
Sure.
All right. You
know
will
we're
have
gonna
time
ask you
today
more
to work on
questions.
that, and I highly recommend that you start it. It's due next Thursday. Let's look at today's class. Not in 2 days, but a week from today. So short turnaround time. Questions? Only questions 1 and 2 today. All right. But 1 and 2 have A through G.
Jesus.
And A through D. So you're not doing 1-1, you're doing 1A and 1B. And all it's asking you is, what function does it match? And if it matches more than one function, then you're gonna call it ambiguous. If it doesn't match any functions, then you're gonna say none. Right? So 1A says object.score_1. So I'm looking for a score function that takes a what? An integer. And how many integers? One. Do any of these score functions take only an integer?
5.
Right? Oh, just one of them.
Number 5.
Number 5, right? Notice this one takes a value, but it's a double, right? The int directly matches.
Yeah.
Right? So your answer to 1A would be? One of them is at least ambiguous, so take it as that. One of them's not.
What lab? 13?
There's about 13. Right? I'm doing like 10% of your life. So we'll look at 2.
Slow down.
Right? This would make a good one for us to just talk about as a class. 2A says, look for a function called score that takes what? One integer. Okay? Everyone go with that function 4 takes one integer?
Mm-hmm.
Okay? Is that the only function that takes one integer?
No.
2. Why does 2 only take one integer?
Because you can have a default.
Right? Basically, I said the second one has a default, right? Meaning it's optional, which means you could call it with just one integer, and it will default the second one to what? A double.
So is that an error, or will it give you both?
So it matches 4, and it matches what? 2, both without type conversion. So it matches 2 functions, which means it's what? Ambiguous. So the answer to 2A is, well, it's not actually ambiguous.
Too soon.
Does that make sense? So you need to do like 1 B through Z and then 2 B, C, and D. Okay? Which gives you time to start your coding assignment.
To go
Get them stubbed out and compiling. You can at least get that by the end of the day. You can just say ambiguous. If it's ambiguous, you can say it. But yes, if it's 1, you say which one. Like the answer to 1A is 5. That's the answer. 2C? 2C says look for a score function that takes 2 doubles. Right, but remember that's an optional argument. So here I'm providing a different argument that will supersede you. So it will. Huh? Questions? I'll pass around a sign-in sheet, so sign that before you leave, and it'll be good.
Okay.
Well, it doesn't exactly. It's like an option.
Okay, so wait. E.
Like basically, the value provided.
So would you just answer type conversion? Or graph? Is that what you want us to?
No, it's ambiguous. Ambiguous. Because it tries to initialize 2 functions and it just freaks it.
I haven't done it in a while. It's not. Your grade is not. Your grade's not effective. It's not worth your time. It's still not. That's fine. Yeah. Saying that, it's actually a couple of C.
With the GP none. Error. Right? I don't know.
No, it doesn't match any of them, so you just put none. Because there's no string in any of those.
Right, so you're gonna try to call it and it's not gonna run anything, it's gonna give you an error.
Yeah.
It's not gonna compile.
Yeah, I know, but the instructions say if they don't match, just put none.
Ah, fucking instructions.
Right, yeah. So just, no, that doesn't matter. So, don't worry about it. If I grade it and like I put a 0 saying that I should remember. Yeah, I think you're I graded it if I could use
This one's in.
Yeah.
I thought it was ambiguous, but then I saw the thing about answering wrong, so I'm not sure which one it is. Because you could type convert, but it doesn't say anything about that.
For what?
The 1G is definitely no.
Technically, can't D be ambiguous as well?
Yeah. Yeah, they were good. They were good for you.
You think so? What do you put the last one?
Last one on number 2? I have to look. What does it say? It's a 1 and a 2. So what is the list of functions it gives you?
So I was thinking, yeah, because even though we passed in a UA.
Yeah. Don't forget, you're probably, if you haven't signed up for classes, it's probably happening sometime this week. Don't forget. Only one section of 21.
Because it has integers. It'll revert to an integer. But this one won't run because it only has one argument. This one's 2.
Yeah. Error. Expected comma or semicolon at the end of input.
I asked.
Oh shit. Undefined reference to distance. Distance double care distance. Oh shit.
So that one would be what I was doing. Yeah, I'll kind of give you stuff. Right, well, there's 3 units per, You can scan it, watch it.
Yeah.
I already signed it. Yes.
It might have been all the way around.
Oh, you put your name?
So how did you make it forward?
I didn't get it.
Don't worry, I'll wait for you.
Ah, that's fine. Someone else's problem. You done?
Yeah, well, it's like another one that's like, what?
Yeah, I.
Really?
No.
I know people that have been intern for like 2
Hey Daniel, when you're done doing that, can you do something for me? Go on Cloud 9, try to compile those 3 files, and tell me if you get the same exact error I'm getting.
Did you put assignments?
Yeah, I did that. No, I didn't.
That'll help.
Hey, try that. No, I'm still getting this. Still getting the same errors.
So you can program.
I don't know exactly what you asked. Where does that go? Yeah, just try to run that. No, like by, yeah. So we have to define all those. Those were defined in the last assignment, right? So what did he say we had to do exactly?
Describe the functions or something like that, or copy them.
Copy them into what file?
I think.
Distance, right there. Or did he say only to edit the other one?
Right. So
No, that one I can just. No, you have to make the functions
Oh,
right.
yeah. So
Because look, it's referencing all those functions. No, but if you go to distance.h, all the functions are referenced right there.
So
Also, it's supposed to answer this.
No, my grandpa said I'm like.
the only thing I can worry about is when it doesn't exactly.
Because I thought this was like one of them, like convert.
No, this one, no, it's not even, this one it does correct, right? It says look for a function.
My neighbor.
It's
My
good.
neighbor was a 7. Like a hospital, and it was a rehab.
The other ones would work for it if that one didn't exist. But if it exactly matches, it will always be.
Yeah, we're gonna put 4 hours, so he's like, "I'm gonna put 25." Oh my gosh, what about? Yeah, exactly. We're not talking.
No laptop. If it's current match, it doesn't even worry about type conversion. So even though it could match something else with type conversion, it's actually accident.
So you gave us 4 files?
That's what?
You gave us what 3 assignments, 3 CPP.
Maybe you put that in there? You should have a folder called 3B, but only has 2 files.
Yeah, and then I have one so the assignment.
That should be.
I'm gonna ask him which files he wants.
Now, 3 is 3A.
You said you need to copy something from
Oh,
CA.
and since there's no.
Yeah, well, because you like subbed all those functions, so you can just copy them over. Or you can just redo them.
Which I don't remember what you said. Which file did you want us to edit in one of these 3? Was it the unit test or was it the other one?
Yeah, that
This one?
That's why it says code here.
Okay, so we're not supposed to touch this one or the other one.
Right. This one, I think this one, if you look, like your name and description goes up there.
Okay, yeah.
But that, there's nothing else you need to
Okay,
touch
so I
on that
don't
one.
touch that at all.
No, but you probably want it open. So what I like to do is I like to put the H file in one of the panes, and then I
Okay.
put the CPP in the other.
Okay.
So, because the directions are in the H, right?
Yeah, so I would read the
directions on the
direction
side,
and
and then
code
you
the
code it
other
on
one.
the other side.
So you said we could just copy these stub functions we made here
Yeah.
over into here somewhere, just like
Just
right there? Okay.
But then if you look at the H file, you'll see that in addition that there's 3 new.
A little scroll.
Yeah.
We gotta probably touch that.
There's 3 constructors that didn't have you right. So
Okay.
you can copy and paste all the
so I
stubs,
have to put
but then
those.
add 3 more. Yeah.
Okay, yeah. Thank you.
Hard? Now let's back to.
So Daniel, what we have to do
We did that.
is you have to go
Yeah, but that was a lot.
that you made.
Yeah, okay.
So you'll have to like download it.
And copy all that
I can't find
into, well, no,
3 is 3 is 3.
where's all the functions you made, right there?
Yeah.
Oh, you commented, okay. So you copy all your functions and you just copy them into the distance.cpp file. But then you have to add the functions that don't exist in that file. So any distance stuff, there's new functions that you have to,
So just copying them, right, and pasting them.
yeah.
So I copied
Well, that was the
Yeah,
last
you copy the functions that are in assignment 3, right?
when I put them here.
We haven't done it. I haven't
Go to
created it yet.
distance.cpp where it says code here.
Yeah.
Or right where it says member functions, right?
Yes.
And then you have to add the other functions that don't exist. You have to go to distance.h and use them in that file. And if it compiles, then you're good. If it doesn't compile, you're fucked. Yeah, so if you look at all those functions, there's like 3 of them that are not defined yet. So you have to define them.
Remember, no, just equals here. Because you don't have, you have no parameters, right? Because here you have computer parameters.
And then, so now you have to redefine it, basically.
Well, not redefine it, but use it. Here you can be like, need to or equal to this.
Okay.
Right, so 5 values for
Meters. Okay. It seems really redundant,
It
so
is
that's why it
redundant.
kind of, I think that's what's confusing about it, is that it's repeating.
Like doing the same thing,
over
right?
and over, so you're like, which part? does what?
Especially with overload constructors, theoretically, they do the same thing, right?
Mhm.
They just take different elements.
Yeah, because it's like pulling from different parts of the program. Okay. All right.
But it should compile now for you on with that assignment.
question.
Yeah.
So these constructors right here that say distance, right? These are the same, they're just accepting different arguments?
Yeah, so there's 3 different constructors, right? One default constructor just going to set meters to 0.
Okay.
One takes in meters, so it'll set it to whatever that value is.
All right.
And the third one takes in a value and then a unit to let you know, right? Because it's not going to be in meters, right? Is it feet? Is it inches? What is it?
Okay. And then I see a couple
So they all
of them that
basically do the same thing.
Then
Yeah.
I have to initialize those in the
Yeah.
distance CPP file, and then if it actually compiles, then that's
Yes.
good.
Oh, yeah.
Later, Daniel.
Well, if you look at the H file, you have the right, this stuff on the top of the right. And then basically, if you go to functions get longer than say 6, the 10 lines of code, 6, 8 lines of code, a lot of them. Then the application is not using the H file to cover that. But when the functions get long, you can write functions.
That's really the this one is
Yeah, you don't need to say anything before. I just need that ID to right? I was gonna give you the money for it. Well, it's in GitHub as well, but if you just look at, remember all of our lectures actually on the
Yeah, so I remember you had like code videos below those too, but I didn't see any for 13.
So this is a good sign, right?
Yeah, compiled, right? And so then eventually you're going to get to a point where you want yours to say the exact same thing as actual.
Yeah.
Right? It's probably right now it's a bunch of garbage values up
Yeah.
or whatever, right? Yeah. So eventually you want everything to match.
All right, cool.
But now you can start working one at a time.